Hello? 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 So normally people introduce you, so maybe I'll introduce myself. Like, hi, my name's Sam Aaron, and I'm going to talk to you today about something which I really care about. And it's really tough to actually try and figure out how to pitch this, because there's all sorts of important aspects, and I could spend hours talking about each and every one. And I guess, because another thing is I kind of give this talk, or variants of this talk, to a wide range of different people with different backgrounds. And so it's really tough to try and figure out what messages to give. And given that you're developers, and specifically Java developers, which is pretty interesting, I'm going to try and pitch this in a way that makes sense to you, so bear with me. The reason why you should be interested is because, and I apologize in advance, but you're all very strange people, okay? I'm strange, you're strange, programmers are strange people. And the world, society, doesn't really understand us. Doesn't really know how to speak our language, doesn't understand our language, doesn't understand the world we live in, doesn't understand the beauty that we see in code, in structures, in information, in process, in forming new ideas, in language, like philosophy, but making it real, making it really happen. And this is an important thing. Like, how the hell do we convince the world that this is an important thing to know about? How on earth do we try and communicate these beauties and these importances in such a way that people can understand more about what programming and computers can do for them? And this is a really fundamental point. And I haven't even got past my first slide, and I can already spend at least half an hour talking about this. And I guess, just to try and put in your head the importance of this, or at least a sort of story which paints the picture. I should probably even say who I am as well. Like, here we are, look. That you saw this morning. Who came this morning to see us play? Brilliant. Okay, cool. So this is MetaX. This is my band, and this is the context we're working from. But I'm also a research associate at the University of Cambridge. And at Cambridge, we do two pretty cool things every year. One is a science festival, and the other thing is called the Festival of Ideas. And these are ways to actually engage in the community and try and share the important, interesting research that happens in the university. And as part of the science festival, I ran a Raspberry Pi stall with the software which I'm going to describe to you. And so it's important to point out that currently my funding as a researcher comes directly from the Raspberry Pi Foundation, so I have a very close relationship with those guys. And so I had this software, which I'm about to describe to you, running on this system, and I'd hooked it up to the special box. Why am I even explaining this before I even told you the system? But it doesn't really matter. And I had a queue of children all wanting to have a crack at this thing. I had a very simple process I was taking them through, and they were enjoying each one. And it was just sort of a 5-minute little exercise. And what they were doing, essentially, was making music, right, by writing code. And we'll get into that in detail. And they were using this device called a Novation Launchpad, which is sort of a pretty cheap, it's like $100, a DJ box of buttons you can press. And the code I was getting them to write basically allowed them to write an event handler, which when they pressed a button, it played a note. It's pretty simple. But one child said to me, "Don't want to do that." So, okay, so what do you like to do? So, well, what I wanted to do is I want to press a bunch of buttons, and then when I press a magic button, I want it to do all the buttons I press one after another and light them up. And he said, "Can you do that?" It's like, well, yeah, sure. It's going to take us sort of 5-10 minutes. And it's going to involve some things that I'm going to have to tell you about, things like state and arrays. And we did it, It spent 10 minutes, we coded it up. And when it worked, this kid put his arms in the air like this, and was like, oh my God, and I ran around the room. All the other parents were like, what on earth is this child doing? And this is a moment I want to try and get you to remember, because we've all had this moment. The first time we had an idea in our heads, and we put it into the computer, and it did something new that no one else has ever seen before. Something that we created in our own minds was real in the real world. And this child was experiencing that for the first time, and it was euphoric. And this is important. We need to teach the world about this moment. We need to teach ourselves to remember this moment, and we need to work out how we can actually get more people to experience this. And yeah, that child, I think, is probably, whether they become a programmer or not, will certainly be affected by that. And the importance of the ability to actually have our own idea and make the computer do that thing is fundamental. Does that make sense? Who can remember that kind of experience? Yeah, okay, so not everyone. So you need to recall back. I mean, there must have been a point in time when you decided, wow, programming is for me, you know? That's the point we want to try and get more children to have. So, and it's not just about children. So this is a workshop I ran, it was like a week or so ago, 2 weeks ago. It was in the local newspaper. And it was a workshop for people of any age. As you can see at the bottom here, there's the lovely lady here. I asked her, why did you come? She said, well, it's obvious. What do you mean it's obvious? She said, yeah, I'm doing a PhD in ancient poetry. So anyone who can make a leap from ancient poetry to computing, or programming specifically, is worth coming along. And then there's a family here as well. And we basically taught them how to write a very simple program, sequential operations. We acted out the code before we wrote the code, and then we wrote it and we made some compositions. And this was great because we got straight to the point, well, I think the point, which was that we were writing code for an actual reason. So one of the children said, oh, Mummy, what we need now is more explosions. So this was the most important thing. And then it wasn't really about, oh, we need more for loops, or we need some variables, or we need some conditional statements. It's, we need more explosions. And of course, I'd already taught them how to do iteration at that point. So to make more explosions, you just make a little loop that went around making lots of explosions. It was great. And so at the end of this sort of 3-hour session, all of them had made a composition that they could play back and had musical elements. And this was great. And so they were able to experience that. So how do we even start with this? So how did I even get to doing this kind of thing? And where was the starting point? So for me, the starting point was about this time last year. And I'd really sort of been cracking with the music system I was working on, something called Overtone. And if you're interested more about the specifics of the technology we used this morning for the performance, we're going to give a talk at 5:50 in room 6. I'll do a little bit now, but I won't go into too much detail, so come to that talk if you want to know more. But I'd built this system, and while I was using it, I had the band, and we were playing and doing some gigs. And an opportunity came up where the Raspberry Pi Foundation said, well, we've got some money to give someone to have a crack at building some tool that kids might be able to use to program with. I was like, yeah, I can do that. I can use my music ideas. And so I quickly built this system, which was exactly for that. But the starting point really is Overtone, right? So let's get this going. So like starting with a terminal, obviously. Let's start this system. So this is what I'm doing here. Is starting. Can you see the screen? It's chopped off the side, isn't it? If I make that like this, and then woohoo! Look at that. You can see that now. Starting a JVM process in the background. And then once it's started, a JVM sometimes takes a while, doesn't it, to get started? Come on, wake up. There we are, started. And then with Emacs, I can connect to it, right? So now I have this REPL, read, evaluate, print loops, a bit like a terminal, where I can put in closure forms. So being a Lisp, we put the function first and the parameter second. And yeah, I mean, this is a great opportunity to explain Lisp for everyone who wants to know about it, which is obviously all of you. Right? Lisp is just very simple. Every time you see brackets, it means do something. The first thing in the bracket is the thing to do, and the rest of the stuff is what to do with. That's all of Lisp. Now you've got numbers, right? That's pretty cool, and strings, they're pretty cool. But really, it's about the functions like plus. And we saw earlier, like, that these things are actual data, and like a function is something you can pass around, you know? It's like a method. Well, these new Lambda things, you know, well, obviously not that new in other languages. But I'm not trying to scare you, and I'm not trying to talk about things. I'm just talking about something that I think is quite easy to explain to children. But anyway, that's by the by. What's really cool is I can sort of pull in this thing called Overtone, if I can spell it correctly. Let's just try and get this going. There we are, look at that. Control-T swaps the letters around. It's like a little game. You think, well, it's probably easy to actually just type it in again, but it's more fun just to play the puzzle. So what this is doing now is it's going through all the namespaces that we've defined, which describe all the different parts of a synthesis system, all the different, like 500 different things, building functions for me to use, booting the eternal superclass synthesizer, and now I have this awesome thing called a music REPL. How cool is this? And so I demonstrate this to kids, you know, in the classroom. I boot this thing up and then say, well, you can just like create a sine wave. So I can demonstrate a sine oscillator. Can you hear that? It's a bit buzzy. If I turn my volume down, and maybe someone else can turn theirs up. Can someone turn the system up a bit? Is that as loud as it gets? Oh well, we have to deal with that. So that's a sine wave, right? As simple as it gets. You can also do a saw wave, which are pretty hideous, but I'm going to play you one anyway. And like low saw wave. It's very quiet, isn't it? It's very quiet. If you have it very quiet, you can hear it. But if I do 2 saw waves, there's like a small difference. Oh no, I've got to type it right. Oh, come on, Samuel. That's the problem when you're coding on stage. Demo, saw 100, 101. You can hear these things that are interleaving. I don't know if you can quite hear that. I'll make it distorted, and then you should be able to hear it. Oh, there we are. And this is pretty cool. You can explain this like when you drop a pebble into a water body, sort of the ripples come out like circles. It's pretty pretty. But if you drop 2 pebbles next to each other, they come out of circles. But when they interleave, where they meet, you get all this really interesting fractal sort of interleaving. And that's what you're hearing with these sort of 2 saw waves happening. And the cool thing here, trying to demonstrate here is that, isn't that you can make some saw waves or something. It's more the fact that I can have an idea, and I can write a few pieces of text, and I can press enter, and it executes. Now, and for the JVM people, what's happening here is actually this text is being passed by the closure parser. It's then being compiled to bytecode, JVM bytecode. So there's classes underneath representing this, all on the fly, in the time it takes you to, before you hear the sounds. And then, in fact, actually, there's further compilation, because then the data structures representing the synthesizer are compiled into a synthesizer design, shipped to SuperCollider via UDP, and then messages sent to trigger it and then kill it afterwards. So there's lots and lots of tech actually happening just in that one line of code. But the cool thing is really that you can actually have your idea, and you can express it in code, and you can hear the results. And you can start to interact with these things. So here's something someone made earlier. It's like Blue Peter in the UK. Development, overtone source, overtone examples, compositions, dubstep, bass. Look at this. So there's a chap called Dan Stoll, a really lovely guy. He designed a dubstep bass in a different language, which is similar, which I've translated to overtone. So that's the original. This is my translation. Actually, we don't want the auto one. Instruments. Here's another version, actually, which is pretty similar, but it doesn't play itself. What I can do is I can play it. So, I mean, it's not the best fidelity, like, bear with me, but the most important thing is this text you can see on the screen is everything required to describe the sound you just heard, and you'll hear again in a second to annoy you. Including the drums, right? There's no pre-recorded drums. That's all described with the mathematics on the screen. Now, that might look a bit alien to you, look strange, but the important thing is there's not much of it, right? And if you spend any amount of time, you'll be able to understand that. So once you've got that thing, then you can control it. So change the wobble to be a slower wobble. Yeah, bassy. I'm obviously tuning around notes, but I've got like functions here, so like 23. Right, obviously I could do that for a while, and you don't necessarily want to listen to it for a great length of time, but the key thing here is, right, with a few lines of code, I can start to interact with the system. Now, this is something which I think is actually more broad and more interesting than children and programming and computing and all that sort of good stuff I'm trying to talk about. This is live programming or live coding, where I have a running process in the background. In this case, it's a bunch of threads on the JVM, and I'm talking to it and saying, change this, do this. And I'm live hot-swapping code in the Erlang sense, and modifying the behavior of the running code as it's still running. And it's not stopping. I haven't got to stop it, recompile, start it, stop it, recompile, start it. It's still running, and I can just keep modifying it, trying things out. And I guess the difference there is like, imagine developing like you're making a clay bowl, you know, where you're sort of forming the thing on the wheel as it's spinning around. and as you're moving your hands, you're seeing the bowl form, and as you're watching that, you make changes. Oh, actually, I think I'll make it thinner. Oh, it's going to be a bit wider. I'll keep it lower. Oh, I'm going to make it thicker. And all these things, you can have a conversation with yourself whilst you're making it, whilst you're observing the thing being formed. And this is exactly the kind of programming style that we're doing here. And I would call it ephemeral programming. So you're programming not necessarily to write code that you're going to save. It's not necessarily going to go into GitHub or into your company's repositories. This is just code that facilitates a conversation that you just potentially just throw away, you know? And in this case, the conversation is one about dubstep and controlling the wobbles. And in the school children's case, it's whatever they want to do, beeps and crazy sounds and donkeys and things. But they don't necessarily keep that code, and it's not something they treasure. It's something you use to actually facilitate, in this case, for school children, the learning process, how they learn how to program. And you can also totally imagine having like big data conversations, you know, like your big data, whatever that is, on some servers, and the client's behind you saying, oh, I've got this big data. I love that phrase, you know, big data. But the client's then saying, how many people are in here who have this properties, or they're trying to find some patterns or observations within the data. And you can totally imagine having a live programming interplay where you're coding some questions, getting some responses, feeding them back to the client in a very fast feedback, so the client can then say, didn't see that, or didn't imagine that, or that's not interesting, try this out. And rather those cycles being that of days or weeks, they can be that of moments, which is much more interesting. And so where I go with this for the children, really, is that I want to say to them, they can start to make this their own thing. And how do I explain that? So let's try and think of this. So if I create a new empty namespace and put it into closure mode. By the way, Emacs is pretty awesome, right? How many pieces of software you still use which are 35 years old, which are still pretty awesome today? It's a great sort of description of good software. Right, what we're going to call it foo, use overtone.live, which I can't even spell. And we're going to use the beautiful overtone.synth.sampled.piano, which is a lovely person has recorded each individual note of a piano in high fidelity and put them in a sort of Creative Commons license, so we can just suck it down for free. And then we can create a function called sample piano, which when we evaluate it, plays the piano, but it's a bit distorted. And now obviously I can change the notes, that's pretty fun. And so here you can sort of demonstrate, like you can say, well, I can, for every note in the scale C4 or 3 minor, play the sample piano on that note. It's all of them. But obviously you can now call Java's sleep for 200 milliseconds or something. You've got a scale, right? So that you're already starting to think, well, actually, this could be pretty useful in a music context. So like the difference between a major and a minor scale. Oh, that's spelled wrong. That's a major. Minor. Oh, who's heard of the Hungarian Hungarian minor? I think there might be a pentatonic. So you can start to explore all these things, actually. It's quite fun. But what you can also do is you can say event debug on. And then hopefully, when I press my MIDI keyboard, which you can't see, which is hidden down here, which is just standard MIDI keyboard using the Java MIDI libraries, you can see on the right-hand side here on the terminal that all this noise is happening. Let's just sort of emphasize the noise. You can see it's just information, essentially, about what's happening. And part of the information is sort of this special key, which is unique for this keyboard. So if I have 5 keyboards connected, because I'm sort of some maestro, they all have different keys. So in here I can sort of turn this off and say on events, and then put that key in, and it was note on, and then I can create a function which takes in a message which represents that information, and I can print hello Devox. Loads of exclamation marks, give that thing a name, foo. And now every time I press a key, you can see on the right-hand side, it says hello Devox, which is amazing. Look at that. The kids love that. They don't think that's amazing? You're not surprised by that? No, of course not. But you're programmers, right? This is the point I was trying to make earlier. Like, you can clearly see that this is an obviously interesting thing to do, you know? But the parents and the children and the teachers they really struggle to, well, when they see this, they think, oh, that's amazing, because you can actually, what? You can change that to say something else? Like, cheerio, Devox? What? You really can do that, and you can redefine it, and it suddenly does something different. What the hell is this? So this is something like we need to try and explain to people. But you think, well, that's not exciting. What I can do is I can print out the note within the message. It's getting a bit more interesting. So now we have some integers representing the specific MIDI note we're playing. And of course then, what we're doing then is standard I.O. We're outputting by printing the number of a note. But of course, we saw before, the other kind of I.O. that's available to us in Overtone is the ability to play the sample piano. So now I've just built a piano, which is pretty cool, right? So in whatever 4 lines of code, I've developed a piano. Now, again, this isn't that exciting, and I'm not trying to convince you that this is like virtuosic programming or anything like that. I'm just trying to show you how it's quite easy to explain to school children that programming is something that they can do themselves, that it's not too complicated. I mean, the code here, it's not about being able to read the code. It's not about the readability in this case. It's just because obviously it is when you can program, but when you're just learning, everything looks alien. The key here is there's just not much of it. And if you spend a little bit of time, you can understand it. And I'm not making any specific arguments about Clojure versus any other language. I'm just talking about the fact that you can write some code, event handler, which can play a sample piano or whatever, make a noise, and it's not too hard. But the point is, the real point, is you say to the children, well, why would you even want to make a piano? Like, they already exist, right? I can buy a little piano from a shop, it's not very expensive. Why would I even want to do that? And the question is really important. And the answer is that only if you really want to. But that suggests that there are other answers. And this is the fundamental thing I'm trying to explain to them. And the reason why I'm trying to explain this to you isn't to try and teach you this, because you clearly know this. It's to try and give you ways to express to other people, because our mission really is to try and share the love of programming with more people. And the way this goes in terms of sharing the love is to say, don't stop at a piano. Like, think of your own piano. Like, what would your piano do? Maybe your piano plays octaves, right? So you're just going to press the one note and it's going to play an octave. So we can easily do that by adding 12 semitones to the current notes, right? So now I've got an octave playing piano. Or you can make a chord playing piano. Let's add 9 semitones. Right, or we can go crazy, right? Let's just make it ridiculous. And the kids actually really enjoy this. Rand integer of 12. So every time I press it, it's playing something else. Completely nonsense, but they like it, right? So the point is that they can make the computer do what they want, not what someone else has told them. And programming languages are our key, our gateway to teaching the computer how to obey our ideas, our whims. And this is a cool thing. It's like, you try and explain to a child how, it's a really good point. Like, how many children only play games where other people define the rules? Like, a really sad child would do that, really. Every child, including yourselves when you're children, and myself, make up new games, or take games and modify the rules, and invert it or cheat or change it around, And that's the creative fun part. And programming allows you to make your own rules. And so this is another thing that I really think it's important to try and convince people, that computers aren't just this thing that have programs that give you specific capabilities, because they can do cool things, and that's pretty awesome. But they can also be a vehicle for your own ideas and your own creative ideas. I actually should have a slide of this. The analogy which I've seen, which really is awesome for this, and again, it's a tool for explaining this to people, is imagine going parachute jumping. And if you're in control of the parachute yourself, you get to fly around, like, just, I'm going to go over there, I'm going to go over there, like this, and that's awesome, right? That's programming. But using someone else's software is doing the pair parachuting, where you're strapped to someone else, and they're doing the and you're just like, oh my God, you've got no control, but you think you might have some control. And so you want to give people more control, and programming and code is a way of doing that. So this makes sense. I'm obviously preaching to the converted. I don't really know why I'm talking to you, maybe. Maybe I should go away and talk to schools more. But I don't know. Maybe if I can try and convince you to talk these ideas to more people, that's a huge win. More people, that's a huge win. Right, so, where are we? Go back to some slides. So this is what I'm trying to do, talk to people, get more people involved. And I've also been convinced that, initially was convinced that we need to teach children how to program, but I'm actually more convinced now that, and it's just a whim, it's just an idea, so maybe I'll change your mind, but it seems to me it's more valuable to teach parents how to program more than it is to teach children how to program. Because the children who are going to fall into programming are going to do that anyway, and the other children aren't ever going to program because no one's actually suggesting it's a good idea. It's like in the government in the UK, there's big movements, but it's still, there's a lot of barriers between having universal quality computer science education. And so if we can get the parents to program and the parents can understand the importance of it, then they're going to badger the schools, and get the code club started and get the after-school club started, and then the children will learn. So I think we need to convince more of the parents and the adults who's like, programming computers, they're not for me. We need to tell them, actually, they're pretty awesome. And so one of the reasons we're doing this band thing, there's lots of other reasons, but it's to try and convince people that programming can be a creative act. It doesn't have to be about making software for banks or businesses, which predominantly it is today. And although that's awesome, it's not the whole picture. There's a whole other a space yet to be explored about using programming in a creative way, just to explore the world, just to have an idea, to be artistic, to play around. And I'll talk more actually about artistic stuff later on. So, another example about how to actually convince people about the importance of programming is this, the chess example, right? So I don't know, maybe you've seen my talk before. I've given this example a number of times, but it's pretty awesome. So, this is the famous rematch, Kasparov and Deep Blue. And this is an important point in the history of chess because obviously this is the point where humans no longer were the most powerful chess entities in the world. Computers are now. At least that's what you all probably think. And who thinks the computer is the most powerful chess entity in the world? Okay, so who doesn't think computers are the most powerful chess entity in the world? Oh, interesting. Well, that's okay. So they're not, actually. They're not the most powerful. I mean, they're more powerful than humans. But there's another entity that we haven't even considered. The cyborg. The cyborg people, they're the best. I don't mean like Cybermen from Doctor Who. I mean just a person with a laptop, like this IBM guy here. Like if you give a person a laptop, they can be the best thing in chess. So this is what Kasparov did. He invented a new game of chess called advanced chess. Advanced chess. Basically, it's chess but cheating. So you'd sit there playing a game of chess, and you'd have your laptop with whatever programs you wanted, like even Deep Blue if you wanted, maybe 5 running at the same time. You would ask the chess program what are some strong moves, and the chess program would suggest them, and then you'd choose which one you want to make, and off you go. And Kasparov said this was amazing for him in chess playing because it freed his mind. He didn't have to worry about whether the pawn was going to get killed by a knightie or the queenie was going to... He didn't have to think about that so much. He could think about the tactics and the psychology and the gameplay and all the lovely things he thought were interesting about chess. And the worrying about whether something was a strong move or not was down to the computer, because the computer only suggested extremely strong moves. And so stronger moves than he would make against the computer on his own. So it gave him awesome moves, and then he chose which were one of the awesome moves to make. And that combination allowed him to beat Deep Blue, allowed him to beat everybody. Except, and this is the point I'm trying to make, they had a competition where anyone could enter using whatever means, whatever software, however they wanted to. So basically, it's a free-for-all cheat chess game. And Kasparov, although he's a grandmaster at chess and he'd been practicing this advanced chess game for ages, didn't win. Right, this is pretty surprising. He didn't win. 2 random guys from America that no one had ever heard of won. Beat Kasparov plus a computer, beat everyone else. How did they win? Well, they built awesome software. They built software which gave them better choices, better vision of the options, a better way to actually perceive strategies. And that software they built gave them such an advantage that they could beat Kasparov plus a computer. That's incredible, isn't it? That's incredible. And what that means is, if this isn't just true in the context of chess, because maybe it's only just true in the context of chess, but if we can broaden it out, if we can imagine that this kind of style of interaction with the world is broader, then where else could it apply? Now, where else could someone using awesome software be better than people who've spent their entire lives working on this particular thing? I think a lot of contexts. And I think that programming languages and programming languages specifically as interfaces, so we actually ask our questions of the system, like which moves to make in chess, using a programming language, I think gives us even more power, and the most power I've ever seen in a way of interacting with computers. And I think it's tantamount to the fact that still many programming experts and computer experts still use the terminal as a way of interacting with the system, because it's pretty badass to be able to write text. It's very terse, you can get quick results very quickly, and it's a very powerful way of interacting. So, and this is how I perceive programming language in general, like a terminal where I'm asking these questions. So, this is another example. If you want to try and convince people why programming is important, you can become the best chess player in the world if you write cool programs. And I want to come back now to music. And it's quite funny. This is one of the oldest computers in the world. Look at the state of that thing. Like a massive computer that only like a few cities in the world owns. Really expensive. And what do people do? They make music on it. So here we are, Bar Bar Black Sheep. Imagine that computer making that noise. Like a millions and millions of pounds business computer. And then people are laughing, right? So there's like a social interaction about that beast of a computer. You know, and so this is pretty cool. So even at the start of when computers were created and operated on, there was still a stream of creative use, you know, and that's what I'm trying to emphasize and talk about. And the cool thing is that the same kind of processing power that was available then, amplified by loads, is one of these guys, right? So we can make this into a thing which plays Bar Bar Black Sheep, and that's exactly what I've done. And this is super cheap. There's more than one per city, Raspberry Pis. I mean, there's some downstairs, actually. There was like Oracle were giving Raspberry Pi devices away, whatever a Raspberry Pi device is, like giving away iPhone devices. But they were giving these away. So where are we going to go with this? So with these things, then you were able to then create an opportunity for people to make music. And if the interaction style, the way to actually make the music is through programming, Bob's your uncle and your dad and your dog, and everyone's happy. So here's some results. Like this is homework from one of the children we worked with. She wrote a program on a piece of paper, which is a program for Happy Birthday. Look at that. It's like you can see the times between the words, and she got a mum to sing this out, which is quite nice. You know, and this is really simple, but it's really important. You know, that she started to understand what aspects of programming. In this case, programming as a sequence of instructions, imperative programming, if you want to be precise with these things. So here we are. This is the Sonic Pi interface. It's super simple. I was like, how do I start with this? I had 3 months to build this thing. And I tried to get Overturn running on the Raspberry Pi. No, it didn't work really. The garbage collector is required to be super efficient for closure because of all the ephemeral objects which are generated all the time. And yeah, it just wasn't up to the mustard. So I ended up using Ruby in this case for this specific thing. Although I think maybe there's opportunities to Java now is much more efficient, so maybe we can get that working again. But for now, I've got this Ruby system, and it's super simple. You write your text in the space on the left, and then any output is on the right, errors are on the bottom right, and there are 2 buttons, play and stop. So I was thinking, how do I actually get started? And this was important for me. I observed these lessons, and I don't know if you can remember school, but my goodness. I mean, the school I went to for these lessons was a sort of an intermediate school. It wasn't super rich or super poor, although it used to be very poor. But the teacher would be like this. You're like, right, children, we're going to do some stuff. And they'll all be running around, you know, like this. And she'd have to get them all to be quiet. And they'd, right, I'm going to say, Johnny, sit down. Tony, get on the... And then she'd say, right, 3, I'm going to say something in 5 seconds. 2, and then they'd be quiet. And then she could inject maybe 2 sentences, right? And then they'd go off doing their thing, and then, right? And so trying to explain to them how to open a new Eclipse project, it's not going to happen, is it? You know, like, even a file path, what the hell is that? A directory structure? No, they're not going to do that. So this thing doesn't even have save. Or file paths or projects or anything like that. It just auto-saves everything. You know, it's just super simple. And all you do is you write the code and you press the play button. So here's an example of it going. So this is running on a Raspberry Pi, which I have SSH to, and it's just X11 forwarding the visuals. So you can see here, I just write the word play 60, and I can press play, and you can hear now they're playing 2 notes at the same time. Bing. And these notes are all synthesized using the same system that I've used for MetaX. underneath the hood, so as powerful in terms of technology. Just the CPU isn't therefore able to generate as much sounds, but the same kind of sounds. Variables, although we actually didn't end up teaching these in the end, we can start to sleep for different times. And the thing is, like, you can get someone who's never programmed before to use this within an hour, and they're already making their own tunes. And they go on for ages. Play, sleep, play, sleep, play, sleep, play, sleep. And that actually, pitch and time, is all of Western music. So that's already enough to describe all of what Beethoven, Chopin, you can do with this, with beeps. Here now, I'm obviously doing a little thing. But you can start to now think about more interesting structures. So, actually, here I'm changing the synthesizer to be a different synthesizer, and then changing the time to be a bit longer. When they hear that, they go, wow, a whole new sound. They go crazy for that. And just simple things, actually, they get quite excited about. And then this is where it starts to get really cool. Iteration, that's brilliant. So Ruby has a really nice way of doing this. So everything between the do and the end I'm about to write is an anonymous function. It's like one of these lambda methods that is passed to the 10 object, which happens to have a times method, which then yields or calls that method its number of times, self number of times. But you get the effect, and so you can start to make these interesting things. And now I'll skip from the rest of that. This was really one of the most depressing things. Like, I got this beautiful card with all these lovely sort of thoughts and ideas, and thanks for doing this, it was brilliant. But Ruth said, thank you for making dull, lifeless computers, interesting and almost reality. That's like, I've just spent 6 months of my life trying my best to work out how to actually make this stuff engaging, exciting. And that's what you get. And that's really the statement, certainly in the UK, of society's perception of who we are and what we do, and our engagement with our own computers and programming and all that sort of stuff. They just think it's dull and lifeless. And so this is our mission, is to try and change people's perception. So it's not dull and lifeless, it's super exciting. It's the thing which allows you to change the world in the most fantastic ways in the quickest amount of time. Like the impact we've had with new technologies is just phenomenal. Yet it's dull and lifeless. I find that incredible. And somehow we've completely failed to communicate to the world about the importance and the excitement of what we're doing. And to me, this needs to change, absolutely. Does anyone agree with that? Are you in agreement with this in general? Put your hands up if you agree, please. More hands up. Could everyone put their hands up, please? Thank you. Right. Where are we? So, I then, after working with the school children, I engaged with artists. This is Rob Smith. He's one of the UK's leading artists. And we got some money from the Arts Council to engage with artists directly to see if we can teach them how to program. These people specifically had very little programming experience, and gave them the Sonic Pi software that we saw. And I then started to expand it out to new ideas to hopefully fulfill their goals for their sort of artistic ambitions. And Rob made something pretty awesome at the end of the project. So this is sort of 4 months in total. We had about 5 different workshops, and I taught them how to use GitHub, and they were putting issue after issue after issue after issue, and I was like, Christ, there's issues after issues. So I was fixing the code and more issues. This is what he built in the end. So he basically put the Raspberry Pi on a big sucker device and sucked it to the window and had the camera module pointing out. And then the camera module took a photo every 20 seconds of whatever it could see. And then it turned that photo into a very low resolution pixelated image, grayscale, and then chose the current line to go through. So there's an index of which line that it was currently on, and grabbed that as a data structure where each gray pixel, I think there was 15 different grays, was an integer between 0 and 15. So they had basically an array of integers within the range 0 to 15. And then he turned those into pitches, and then played the notes of that row. And then he had a special pitch for the end of the row, and then for each of the rows in the picture, he had another special pitch. So he made a system that could communicate the image across the airwaves, like a modem, essentially, or a fax. It was super slow, like, burp, burp, burp. But he's an artist, right? So that was always interesting for him. So you can see down here, like the cables from the thing are down to speakers which are playing the image that it's seeing. And then he wrote, not with a Raspberry Pi, unfortunately, we'll we'll work on that in the future, but we had a short amount of time. Using his Mac, he used something called Maximus P, which is an audio programming system, where you program by dragging boxes and lines. So really nice, sort of simple, non-textual language that he could understand. And he programmed a decoder, which then drew the picture back on the screen. It was awesome. So you actually saw this picture, very pixelated in grayscale, that the Pi was seeing on the other computer, and when the information was traveling through the airwaves. And then you can get into all sorts of questions about, is this art, and what is art, and that's not for me to even try and talk about. What I was interested in was, does this artist think that he's making art himself? And the answer to that is yes. And then also, the secondary thing is there anything I can steal for kids? Is there any ideas I can hear? Clearly, this is like a whole bunch of lessons about how we can represent information, how we can structure data, how we can take an image, convert it to numbers, turn the numbers into pictures, play the pictures in the speaker, have a microphone, listen to those pictures, turn it back into numbers, draw the image again, you know? And his inspiration, this was super interesting, I found, for all this, was NASA. So in the early days, NASA was getting information, I think it was from Mars or the Moon, I'm not quite sure, I think it's maybe Mars. But the computer capabilities on the base station, ground on the Earth, weren't that great. And so as the numbers were coming in, there was like a chap with the different coloured pens colouring in the mosaic on the wall. And they have this picture, first picture I think it was of Mars, which is painted, like paint by numbers. So this was the idea he was taking, and this is exactly the same kind of thing. One of the other artists produced something really interesting. She produced a performance. So she actually wrote code whilst using the computer, and the first thing it did was, the first point of the contact was through her event handler. So when she pressed the keys, it would play back sounds of really loud key presses, which sounded a bit weird, so it was being echoing. And then she would write more code, which modified the code to do new things, so essentially adding new event handlers. So instead of when she pressed O, instead of hearing the keyboard being pressed again, she would hear a special sample or her voice. And so the computer's reaction changed through time as she was typing things in and as she was evaluating code. And this was pretty exciting because this is essentially what we do as MetaX. You know, this is a live programming thing. This artist figured this out in a few months. So she's essentially writing event handlers which are modifying through time, modifying a running process. So she's live coding her performance. I think that's pretty awesome, right? So that was great. And these things, they're on the news, right? Look at this. So, here's me on the BBC. That's crackers. I was on it for like 3 seconds, I think, in total, maybe 4. And I was saying, you can speak through computers. But people are really picking up on this. So time is right to talk about these things, is to share the love of programming, to express these importances. And if things like the BBC are taking part, then that's great. I gave a Sonic Pi workshop at a school in Cambridge, and they recorded it. And the kids are all like playing, making notes, and having a good time. And then they interviewed me, but I made a right bodge of it, so they didn't have that. They just put my face. That's the way it is. Thank you. Well, I've got more to show you. I've got 20 more minutes. So I'll show you what I've been working on in terms of the sort of the latest development of Sonic Pi. So where are we? So if I create a new terminal, Dropbox, lab code. Defining Pi is called. So this is sort of an experiment of how I can actually work with it. So this runs on the Raspberry Pi, although I'm actually executing it on my local machine. It's just a simple a web service which talks over WebSockets and presents you a web interface. Oh, this is pretty cool. I think it's gone now. Localhost 4567. Look at that, looks exciting. So I didn't really spend any time making it look pretty. It wasn't really the goal. But what you got here is the same thing. You can write here, play 60. We've got a thing we can play. So this is like, if you're ever going to build stuff for kids, I'm not saying you should use this system, but the lessons I've learned from it is that if you can make something super easy to get started with, right, so that the getting started point is just writing a few letters and hearing something or seeing something or perceiving something which matters to you. So this isn't, let's do the Fibonacci sequence, you know. It's not what's the length of of the triangle or any like these maths thing. It's something which has a real effect in the real world. The time that you have to actually get in that should be really tiny. And then the ability to modify it and hear the modification should be there as well in terms of really simple. And then the kids, that's enough for kids to spend over 2 hours with, right? That. Well, actually, not just that. That and sleep for 1 second, play for 78 and sleep for 0.5 seconds and play whatever, 50. Right, that's enough for them to spend hours with, and I've observed it, and they go crazy. They fill the screen with play, sleep, play, sleep, play, sleep, play, sleep, play, sleep, and they love it. And they're actually in control of the computer themselves. And it doesn't matter what they're producing. It doesn't matter that it's necessarily musical or not. What matters is they feel like they are in control. And the time it takes for them to actually get a result quickly is really small. And the time it takes for them to have an idea and to perceive that idea in their new code should also be really small and not complicated. But once you've got that, and once you've got their attention, because this really gets their attention very quickly, because they're in control of the computer, then you're able to say, what you're able to do is you observe them doing something like this, right? I can't actually type. They'll have programs like this. Oh, what on earth is this? And they think, well, crikey, there's a lot of repetition now. Well, we know how to solve repetition. We saw it before. You use iteration. And so suddenly, rather than, because this is one of the things actually I observed, when we try to teach some fundamental concepts like variables or abstractions and methods, they just didn't really get it. Like, why do I need this? Why do we need a method? Why do we need to put that thing and all that stuff? And if you're teaching Java, it's even more complicated. Why do I need a class? Like, what is a class? Like, you shouldn't even start with a class. You should start with some action. But try to explain that to children is they just get bored and it doesn't make any sense to them. But the reason why we need a class, certainly in object-oriented languages, is to start to structure large code bases. That's why we have them. There's a way to modularize things. But you only need that if you've got a large code base. If you're starting off with play 60, you don't need a class. And so when they have the problem like this is a problem, got too much code, then you can say, well, actually, have you noticed that you're doing the same thing 5 times? Wouldn't it be really cool if you could just write, let's delete all that, 5 times, do, and end, and suddenly they understand that. They go, oh, that's amazing. Yeah, that makes a lot more sense, and then off they go. So this is a really important thing. I mean, it's not very musical, is it really? But it's doing it 5 times. And so you start to teach the structures that we use every day when they're actually useful, when they're serving a problem or a demand. Same for conditionals. Isn't it doing the same thing every time? Isn't that a bit boring? Wouldn't it be interesting if it maybe did something different every time? Maybe you could throw a dice, and if it was a 1, you'd play this note. If it was a 2, you'd do this note. We've got this thing called a conditional, and random. So if you use a condition or like a case statement, or you start to add these things in when they need them, it's very powerful. So that was pretty cool. What did I do? I've added recently, the ability to play samples, which is pretty fun. They really like that. So I've got a bunch of samples here that I've just downloaded from a really cool website called freesound.org. Donkey, that's an awesome one. Let's get that going. So I'm not going to do it 5 times. Just sample, and then you pass it a path, users, sound, desktop, samples, donkey. Ha ha ha! They love that. They love it. And so you can obviously, you start to make their own, they could record their own samples. It's a way to actually say, again, it's how you can store information. Like, you can take a recording, turn it into numbers, put the number on a disk, and then you can take the disk to another computer, you can turn the numbers back into sounds, and then you can hear it. And then you can do things like stretch it out or shrink it, because it's just numbers. So I can change the rate of this to 0.5, and got this crazy warped-up donkey, more like a cow. And again, the children's face, just adding that rate 0.5, their mind explodes, the possibilities, because they think, well, okay, I could change that number to whatever I want. Yeah, go for it, like add 3. And already it's fun, right? And so they're in this loop of, I wonder what it sounds like if it's 30. It probably sounds dreadful. Let's give it a go. And then suddenly you've got this crazy sample thing. So then I can have that, and then maybe there's we have the Atari wires, which is pretty crazy. Let's not have it at rate 30. So you could sort of start to structure sound by sleeping for 0.25 seconds and then. And again, they can just start doing this, there's like having a go and just changing, and maybe there's some kick drum there. So let's get that going. Oh, and this is the other really super interesting thing. There's lots of interesting things. And feel free to grab me at any point the rest of this conference, and if you're interested, and I'll happily talk to you for ages about ideas I've got and things that happened. Was that, they weren't using samples, that's a recent thing that came from the working with the artists, was there were writing these melodies and bass lines. We say we're going to write a bass line, and what's the interesting thing about bass line? It's low notes, we use low numbers, and typically a bass line repeats. So we're going to use this iteration thing to actually describe a bass line. So they've got this bass line repeating, and they made this little melody to go on the top. And in sort of 5 weeks, so we did a lesson every week, we were doing this, and the children were saying, it's not very good, I was like, what do you mean it's not very good? Well, I can play the bass line, and I can play the melody one after another, but that's not really what I want. And about 3 children independently had this conversation with me. What I'd really like to do is play them both at once. I think, crikey, how am I going to do that? Threads. I'll teach them threads. So lesson 5 at Introductory Computer Science in my course, Sam Aaron's course, is threads. And actually it makes complete sense, because threads are actually pretty easy. They're only hard when you want to coordinate the threads with state, or when the threads are actually trying to access the same things. But we haven't taught them state. They're not doing variables at this point. And so coordination of threads doesn't happen. So it's just threads happening at the same time. So because they're not talking to each other, there's no real complication. And so you can say in threads do, and then ends. And I can say while true. So get this beat going, and then maybe put him at the top. So I've suddenly got this rhythm going. That's pretty cool. And I can delete him and start to. Suddenly I'm making music, right? That's like 3 lines of code. Well, you can see it's almost the same as the overtone stuff, right? But this is accessible to children. So, obviously I can do that for a while. I've got an issue with the threads, they don't start very well. Experimental code, you're like, oh, come on. That does it. Control C. Yeah, actually I fixed it in the version I've sent to one of the teachers working with it. But there you go, right? That's 5 lines of code, and you're making a simple thing. And really, I'm being really, really, really honest about this. There were children in the workshop that I showed you, with the picture of the paper, who were doing that after they'd never programmed before in 3 hours with their mum. Okay, so this really is accessible. I'm not saying, well, wouldn't it be really cool if we could teach? Really, this kind of stuff is possible. It's just, I think the lesson is to make it as simple and easy to get started as possible, and making that barrier as small as possible. I've got 8 minutes left, but I really think it's probably wise now, if you've got any questions at this stage, just to open it up and just to take it from there in terms of any things that you specifically want to talk about. Question? The question is, what's the age of the kids? Well, the children I work with the schools were Key Stage 3 in the UK, so that's 11 and 12. But I think actually that's quite old. But I think as soon as they can read and write, I think that's the age that they can work with. It's just in the UK, no one can program. So 11 and 12 it works with, 15 and 16 it works with, 67 it works with. It doesn't really matter, just as long as you can get engaged and work with these things. Any more questions? No more questions? One more question? Yep. So the question is, does it help to understand music composition? The question is, does it help to compose new music? I think that's an interesting question. I think that to get started with this stuff, I think the musicality part is not interesting and not important. I think it's just them being able to, make their own sounds and then be able to have their own control. So their own agency is probably the most important part. The musicality, whether it sounds musical or not, that I've not observed that as being an issue, you know. And so some of the children have come in knowing what scales are, and knowing what arpeggios are, and knowing how to make a melody, and other children have got no idea. And you just say to them, higher numbers, higher note, lower numbers, lower note, go for it. I think if you start to play with this for a long time and start to use it for its actual purpose, which is to make music, then I think the musicality becomes clearly an important part. But when you're using it as a tool to engage children in programming in just a starting point, I don't think it matters if they're making crazy sounds or beautiful compositions at that point. But it is interesting that we've just asked money from Nesta, which is an innovation design fund, to try and use this software, these ideas, to not teach computer science, but to teach music. I think that's pretty interesting. So taking a computer into a music lesson, not as a garage band, but as code. Pretty crazy. And using the Raspberry Pis, so to make crazy Raspberry Pi orchestras. Imagine that. Imagine networking a bunch of Raspberry Pis, having everyone synchronized, playing songs, and working together could be quite fun. So at that point, then, musicality does become interesting. So I think it's a later concern. Any more questions? Yes? So the question is, where can you find tools like this? So Sonic Pi specifically is available. So they've got the Twitter thing down here. So where can we find that? Make that big. So Sonic_Pi in the bottom right is the Twitter account for Sonic Pi. And there's also the URL there as well, sonic-pi.net, which just redirects to a crazy long University of Cambridge, sonic-pi.net. So this is actually cl.cam.ac.uk/project/raspberry-pi/Sonic Pi, but that's not very easy to remember. And this is information here. There's information for teachers. There's a Creative Commons licensed set of lesson plans which you can download, which are all freely available, which introduce how it works and introduces the concepts and talks about how you can introduce these concepts by acting things out first before you actually get to the code. And there's a community thing. So we have a mailing list, Google mailing list you can join, where people are actually sharing their code and having conversations. There's a cheat sheet you can download. Download the cheat sheet? Was that a broken link? There we are. So here's the cheat sheet. So this is the full API, if you're interested in that kind of stuff. Oh yeah, you can do things like change the attack and release for notes. So you can start to actually structure these things interestingly. And I'm always adding now more and more musical functionality, which is pretty fun. And yeah, does that answer your question? Is that enough? Yeah. So yeah, so all the stuff's available. And of course, I'm online, so if you've got any questions specifically about Sonic Pi, you can always ask me. Oh, and also, this is the most exciting thing. If you download the latest version of the Raspberry Pi operating system, Raspberry, it's on there. So that's pretty cool. So now I've sort of Trojan horse put in Super Collider and synthesizer systems into all Raspberry Pis, which is quite exciting. Any more questions? Yep. This specific version, so the question is, do you need a Raspberry Pi to run this project? This specific version, it's on GitHub, github.com/samaaron/defining-pi. I don't support it, so you can run it. It uses WebSockets and the browser part's written in ClojureScript. It doesn't need a Raspberry Pi, no. It runs on the Mac out of the box. But going forwards, currently at the moment, all my development efforts specifically for the Raspberry Pi, because I think that's an interesting platform to work on. But again, all the source code is open source. It's on GitHub, so you're free to port it to whatever system you want. And I think actually that would be great if people could spend some time porting this to Windows or to whatever. But an interesting point is in schools, schools will say, well, we need Windows because all our computers are running Windows or something like this. The amount of effort it is to get a piece of software on the school computer system is incredible, right? Even if it's Windows. But taking a Raspberry Pi in, suddenly you can put whatever system you want on there because it's not networked. They can't get to the dodgy websites. It's just a little box with a speaker and a keyboard. So actually, even if it's running Linux and whatever it is, getting a Raspberry Pi into the computer at school with whatever software you want on is a much easier proposition, I've found, than trying to coax the sysadmin to put whatever software you want on, because you've got to go through a whole load of issues with that. Any more questions? No? So hopefully you're all going to go away now and start to dribbling and drooling about the importance of computer science, like ravaged beasts, just running around going, computer science, and telling everyone, all your friends and family, about how important it is. We need to teach our children, and not just teach our children, we need to teach their parents, and their parents, and their parents if they're still alive, everyone. And the more people we can get involved, the better, and the world's going to be an amazing place.